The Volkswagen Group had its first Power Day yesterday, where it unveiled its technology roadmap. It's basically a strategy to overtake Tesla as the number one electric vehicle manufacturer in the world. And this is Volkswagen's declaration that it is all in on electric. So to discuss that, I'm going to talk to Sam Abuelsamid, who's an EV analyst with Guidehouse Consulting. So Sam, welcome to the interview.
Good to be back with you again, Markham. How are you today?
I'm just fine, thank you. Now, this is a big deal. Volkswagen really laid it out on the table here and made its ambitions known. There's a number of pieces to this roadmap. So let's start with your overall take on the on Power Day.
Yeah, so Volkswagen for a couple of years now has been moving very aggressively towards electrification. They announced some time ago that they plan to have 75 battery electric models off of their MEB electric platform by 2025, plus additional models off their premium platforms for their brands like Audi and Porsche and Bentley. But for with all these manufacturers that are talking about shifting completely over to electric vehicles over the coming decade, the big thing that's left is batteries. It's one thing to develop the vehicles, but you also have to have a lot of batteries, and that's what Volkswagen announced yesterday. They're going to be building. They're not just sourcing batteries from suppliers like LG and Samsung and CATL, but also producing their own batteries. They're going to build 6 battery factories in Europe by the end of the decade, with 240 gigawatt hours of capacity to support their vehicle production in Europe. And that's something that needs to happen globally. Here in the U.S., we also had a big announcement from LG Chem last week that they are going to build 2 more factories here in the U.S. By 2025, adding another 70 gigawatt hours of capacity, which is just a start for what we're going to need if we're going to get to 100% electric vehicles.
Well, let's talk about the types of batteries, because Volkswagen was talking about a new unified cell that will deliver, it'll drop the cost of batteries significantly below $100 a kilowatt hour, and also lead to all sorts of other benefits like higher energy density. You're an automotive engineer. What's your take on this new cell design?
So there's a couple of things going on here. VW's current battery pack design is already set up around a common module format. So batteries, are assembled. You take cells, pack them into modules, and then put a bunch of modules into a pack and put that in the vehicle. So they're already using a common module design, but the modules can accommodate different types of cells. So they're in some vehicles they're using prismatic cells, like the ones that Samsung produces. In other cases, they're using pouch cells like those from LG Chem. What they're going to now is a standardized cell format. So they're going to use exclusively prismatic can cells, large rectangular in a metal case. And regardless of which vendor they're coming from, whether they're in-house or from one of their suppliers, they're all going to be the same format. So getting to that common format reduces the number of different kinds of parts they have to stock, commonizes everything a lot more, and helps drive down the cost. And then the other aspect of this is the move towards solid state cells. VW is a major investor in a company called QuantumScape, which went public earlier this year. And they are producing they're developing a lithium metal solid state cell that it's hoped, once they can scale up production of that, can again significantly reduce cost by simplifying the cell construction, also eliminating most, if not all, of the cobalt, and also improve the energy density, almost double the energy density.
Now, there's an interesting wrinkle to Volkswagen's approach here. They're going to also get into or support the battery recycling business, and they're looking at getting up to 95% of a battery recycled. And I guess if you're a manufacturer who's worried about the availability of critical minerals and metals, that strategy makes perfect sense.
Yeah, if VW intends to build its own cells, or even work with suppliers to do that, if we're to build all these cells requires a lot of raw materials, and some of those raw materials today come from, shall we say, problematic parts of the world in terms of environmental impact and societal impact and where they're mined, and reusing those materials from batteries that are no longer have enough useful capacity for use in a vehicle is going to be key to reducing the total environmental impact of EV manufacturing, and also driving down that cost, reusing those materials. Last week, VW released a video showing their initial battery recycling line, which essentially starts off with a giant shredder that takes you take cells and actually modules full of cells, drop them in this shredder, and it shreds all this metal and other materials into little slivers, and then it goes through a series of steps to process it and extract the raw materials from it so that it can be used back in new cells.
Now, the another part of the announcement was that VW is going to invest significant money in the growth of public charging infrastructure. And they're going to do this with partners like BP, the giant oil and gas company, but they're also going to do it in China and the United States. How important is this part of the announcement?
This is really crucial to expanding the addressable market for EVs. One of the challenges, today, the EV market it's a tiny slice of the overall vehicle market, and most people that drive EVs live in single-family homes where they have access to a plug or a charger, so they either have a driveway or a garage. Especially in Europe and in cities, a lot of people don't have a garage where they can park. And so they're often relying on street parking or public parking garages, things like that. So in order for all of those people to be able to reasonably make that shift to EVs, they are going to need to have access to reliable and fast public charging. So VW announced that they're going to be adding another 18,000 DC fast charging points across Europe over the next several years. And they're also expanding here in North America with Electrify America and Electrify Canada, as well as in China with other partners over there.
I suppose there's some implications here for their adoption of solid state batteries as well, because my understanding from our previous conversations is that solid state takes a fast charge much better than other designs. And we could be looking at, charging times of maybe 15 minutes. And at that point, it almost becomes like filling up a gasoline car.
Yeah, absolutely. Again, especially if you are reliant on that public charging, if you don't have access to charging at home, if you can charge at home, you can plug in overnight. You don't need fast charging, no problem. But if you are reliant on public charging, not having to sit around waiting for the vehicle to charge is going to be extremely important to getting consumers to adopt this technology. And so the combination of batteries that can accept the charge faster and more charging infrastructure together is a key to creating this electric mobility ecosystem.
Right. And finally, Volkswagen is also looking at integrating the EV batteries into the power grid. So basically, you've got electricity flowing both ways. The EV at any time it's plugged in, that power could be used by the utility. We see more and more of these kind of announcements coming out. How important do you think this particular announcement is?
Yeah, so there's two aspects again here to what VW talked about. One is the vehicle to grid integration, which I think is going to be important, but I think it's probably going to be more important for fleet operations, fleets of electric vehicles, where those vehicles can be parked at certain times of the day when you need those vehicles plugged in to act as a buffer, a stationary storage solution for the grid, more so than for consumers, because consumers are less predictable. But The other aspect of this is the second life use of the batteries. Once, no matter how carefully you handle a battery, over time it's going to lose its capacity to store energy. And at some point, it gets to 60 or 70% of its original capacity. The customer is not going to want to use that in the vehicle because you're going to lose too much of your range. So at that point, the battery can be replaced with a new battery, but that even if it has 60% of its original capacity, that can still be used in combination with other battery packs as part of a stationary storage solution which is crucial for renewable energies solutions like solar and wind. You really need to have that because, again, solar, you're not generating solar at night, but you still need power at night. Similarly with wind, it's inconsistent. So taking those used batteries for second life applications can dramatically extend their useful life and make solar or make renewable energy much more convenient.
Final question, Sam. I've interviewed a few other experts over the last few weeks who are talking about kind of a global clean energy, clean technology arms race between China, Europe, and the United States. And electric vehicles and batteries are probably two of the key technologies in that arms race. Do you see the competition between these regions and manufacturers and governments, I guess, shaping up like that?
I hesitate to use the word arms race, but yeah, there's definitely going to be a competition, especially for the raw materials. That's a key component of what's needed here, both things like rare earth metals as well as the electrochemical materials in the batteries like lithium, cobalt, manganese, and so on. And right now, some of those key materials are primarily sourced from China. So being able to diversify the sources of the raw materials is going to be crucial in order for everybody to have access to it, and also to drive down costs. And then everybody wants to have some degree of self-sufficiency in their energy store or energy systems and their transportation systems. You don't necessarily want to be too reliant on any other countries, especially those that might potentially be political adversaries.
Sam, thank you for this. Interesting insights as always.
Always happy to chat with you, Markham.